More than 2,000 years ago, the distance that a Roman marching legion could cover in 1,000 paces was said to be 1 mile. In the 1300s, King Edward II, King of England, declared the standard measurement for a foot based on the length of his own foot. He also stated that an inch would be equal to the length of 3 barley corns, and that a foot would be equal to 12 inches. Today, even though Canada and most of the world have switched to the metric system, which uses kilometers, meters, centimeters, and millimeters to measure distance, we still use the imperial system with feet and inches for much of the measurement in the construction industry. There are quite a few reasons for this. Most buildings are designed and built using imperial measurements. Frame spacing, doors, and windows are all designed to match up in imperial measurements. Carpenters, electricians, and plumbers are all trained using this system. Building codes, plans, and tools all align with standard imperial measurements such as 2x4 lumber, 4x8 plywood sheets, and 16-inch stud spacing. To switch over to the metric system would require many changes that would ripple through many industries and be very costly. It is very unlikely that the use of imperial measurements in construction and other trades will change anytime soon. Imagine this line represents 1 mile. A mile is made up of 5,280 feet. If we zoom into one of those feet, we can see that a foot is divided into 12 inches. Zooming further into one of those inches, we can see that an inch is further divided into fractions of an inch. On any standard tape measure, these fractions of an inch are shown using lines of different sizes. The longest lines, shown here in red, indicate a full inch in length. So in this diagram, the distance from one red mark to the next is 1 inch. The next longest line, shown here in blue, divides the inch in two and indicates the half-inch mark. Notice how the distance from the inch mark to the half-inch mark is half an inch, and the distance from the half-inch mark to the next inch mark is also half an inch. The next longest lines, shown in purple, further subdivide our tape measure into quarter-inch measurements. This pattern continues so that the next longest lines, shown in green, divide the quarter-inch marks in half. This indicates the 1/8 measurements within the inch. Finally, the smallest ticks on the tape measure, shown here in orange, divide the 1/8 marks in two and indicate the 1/16 fraction. Let's take a moment and look at the number markings or fractions on our measuring tape. If we were to travel across our tape measure 1/8 of an inch at a time, our journey would look something like this. We will start at the 0 mark and travel 1/8 of an inch along our tape measure. As expected, we arrive at a marking that says 1/8. Now let's travel another 1/8 of an inch across our tape measure so that we have now traveled a total of 2/8 of an inch. Instead of seeing a marking for 2/8, however, we see a marking for 1/4. Why is this? The reason is that 2/8 is not the simplest terms in which we can express the fraction. 2/8 is equal to 1/4, and since this is the simplest term for expressing the fraction, the markings show 1/4. All fractions on a tape are always displayed in simplest terms. If we travel another 1/8 of an inch along our tape measure, we then come to a marking that says 3/8. Traveling another 1/8 of an inch along the tape measure, we come to a marking that says 1/2. Again, we might have expected 4/8, but since this is not the lowest or simplest terms for expressing this fraction, it is instead written as 1/2. The next 1/8 of an inch takes us to 5/8, which is marked as expected, And the next eighth of an inch is listed as 3/4 because the simplest terms for 6/8 is 3/4. Traveling another eighth of an inch takes us to 7/8. And finally, the last eighth of an inch of our journey takes us to 1 inch because 8/8 is equal to the whole number 1. Let's put those measurement skills into practical use now. Take a look at this piece of wood that we're trying to measure. We might be tempted to say, oh, it's about 3.5 feet, or it's sort of around 42 inches. This is imprecise and would be considered unprofessional on a work site. To get a clearer idea of just how long this piece of wood is, let's zoom in a little bit. Looking more closely at the tape measure, we could say that it is 3 feet, 6 inches and a bit, or 42 inches and a bit. We take pride in our work, however. We want to be very exact in our measurements to get the best results. So, looking even more closely, we can see that one piece of wood is 42.5 inches long. We could also state that as 3 feet, 6.5 inches. Measuring this piece of wood, we see that it is longer than 18 inches and lines up with the third shortest line on a tape measure. The third shortest lines indicate some 1/4 inch marking. Moving past the inch mark, we see that it is the first 1/4 inch mark that we come across, so we can say that the wood is 18 1/4 inches, or just 18 1/4 inches. We could also state the length as 1 foot, 6 1/4 inches. The next piece of wood that we are measuring lines up with the second shortest line on the tape measure, which is an 1/8 inch marking. Counting past the 44 inch mark, we travel 7 of these 1/8 inch of an inch markings. So we can say the wood is 44 7/8 inches. We could also state the length as 3 feet, 8 7/8 inches. This wood is slightly longer than 37 inches. The end lines up with the shortest tick on the tape measure, which marks some 1/16 of an inch. Counting past the inch mark, we see that it is 3 1/16 past the inch. So we say the length is 37 3/16 inches. In feet, we could call this 3 feet, 1 3/16 inches. This is the level of precision we should look for in our work.